In this video, we discuss learning outcome number 4 of lesson 6.4, which is about the finite population correction factor. So there are some assumptions underlying our use of the formula for that standard error of the mean, or the population standard deviation for the population of sample means. When we're sampling with replacement, it doesn't really matter how large that population is. When sampling with replacement, we can sample indefinitely. Because if I have a population and then I choose one and then I put it back in and then I choose one again and then I put it back in and then I choose one again and I put it back in, because I am putting that item back in and then choosing again every time, that's sampling with replacement. The population can be is effectively infinite. We could do that as many times as we want. Well, the formula that we used earlier, the one that says that the standard deviation of the sample means is equal to the original population's standard deviation divided by the square root of the sample size. That's assuming that that population has infinitely many members, which is a fine assumption as long as we're sampling with replacement. But if we're not sampling with replacement, if we're sampling without replacement, so we choose 100 and we're not putting any back in as we're choosing. You choose the first one, you choose the second one, you choose the third one, you keep going. If we're sampling without replacement that way, and the sample size is greater than 0.05 times n, where n is a population size, or alternatively, what that inequality says is that our sample size is more than 5% of the population size. So that's when that 5% guideline for cumbersome calculations does not apply. Then we've got to do something else. Then that sample standard deviation for the sample means, or I said population standard deviation for the sample means, is not going to be accurate. It's not going to accurately reflect the variation in that data set. In that case, the standard deviation of the sample mean should be computed using this formula. Basically what we do is we take the old formula and we multiply by this extra factor. It's the square root of the difference between that population size and the sample size divided by the difference between the population size and 1. That extra factor is called the finite population correction factor. Everything else will stay exactly the same. The mean of the sample means is still equal to the population mean. The standard deviation is just a little bit different, but we can still use the normal distribution as an approximation. It's just that this would be the appropriate standard deviation for that normal distribution. Now you're going to use this whenever you're sampling without replacement or when the sample size n is more than 5% of the original population size. And I think there's only one homework problem in your book that uses this formula, and I don't believe I assigned it in your homework. So you really don't have to worry about this too much. But I wanted you to be aware of this formula just in case you are in a position where you're sampling without replacement and your sample size is larger than 5% of the population. In that case, the things that we've learned in this section can apply, but they have to be modified a little bit. You would have to use this as your standard deviation of the sample means instead of just this first part.